Here we are in the middle of chapter 3. We talked about what temperature was and how it's a little bit different than heat. How do we measure temperature? Well, that's something that we're familiar with because when you're ill and you have a fever, you take your temperature. And we listen to the weather. We want to know how hot it's going to be. So there are 3 different temperature scales that we're going to encounter in this class. The first is the Fahrenheit scale, and that's what we use in everyday life. You know, if it says it's going to be 95 degrees outside, that means Fahrenheit. Room temperature on the Fahrenheit scale is about 72. And then we have the Celsius scale. This is a metric scale. It's based on factors of 10. And here room temperature is about 22 degrees. And then there's the Kelvin scale. And the Kelvin scale is used for gases. These scales differ in where 0 is. So on the Fahrenheit scale, well, let me start here. Let me start with Celsius. On the Celsius scale, 0 is assigned to be the freezing point of pure water at atmospheric pressure. So that's what 0 is. On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit. 0 was actually defined as the temperature of a saturated salt solution when it froze. And boiling point of water is 100 degrees Celsius. On the Fahrenheit scale, that's 212. So between the Fahrenheit and the Celsius scales, we have different zeros and we have different sizes of units. When we convert on temperature scales, we cannot use dimensional analysis. When you measure lengths in meters or inches or whatever, you can do dimensional analysis because the zeros are in the same place. 0 is 0 in length. But in temperature, we define what 0 is. On the Kelvin scale, the 0 here is defined as absolute 0. That is the lowest theoretically possible temperature, the temperature at which movement of all particles stops. So where the kinetic energy of the particles would be 0. On the Celsius scale, the difference between boiling and freezing of water is 100 degrees. On the Kelvin scale, it is 100 kelvins. The Kelvin scale does not use degrees, it uses a unit called a Kelvin. On the Fahrenheit scale, the difference here is 180. So we have to use equations to convert between the temperature scales. So if we have Celsius temperature and we want to find out what the Kelvin temperature is, we take the Celsius temperature and we add 273.15. That gives us the Kelvin temperature. If we want the Celsius temperature and we're given degrees Fahrenheit, we subtract 32 from that and then divide that quantity by 1.8. When you talk to your calculator, you have to be careful here. You may need to use parentheses, or you do this temperature minus that temperature and then press equals before you divide. Otherwise, it will misunderstand what you want it to do. So these equations are important. Let's try them out. Let's convert Kelvin to Celsius. So temperature conversions, we need an equation. So these are the possible equations. I will give these to you on an exam. It'll be in the information at the top, okay? But you have to know how to use them. So this is the one that relates kelvins and degrees Celsius. So that's the equation we're going to use. So I'm going to write down the equation. Kelvin equals degrees Celsius plus 273.15. Here I'm given a temperature in kelvins and I'm asked to convert it to Celsius. I need to rearrange this equation. I want degrees Celsius by itself. So what I'm going to do is I'm going to subtract 273.15 from each side of the equation. The important thing to do when you're rearranging equations is to do exactly the same thing to both sides. So now on the left we have Kelvin minus 273.15, and on the right we have degrees Celsius plus 273.15 minus 273.15. So that's just 0. I'm just going to rewrite this equation so that degrees Celsius is on the left. Degrees Celsius equals the temperature in kelvins minus 273.15. So now I'm going to plug in 358 Kelvin for my Kelvin temperature. I'm going to subtract 273.15. And my calculator shows me 84.85, and the unit then would be degrees Celsius. Now, any questions about the math part? What do we do with significant figures? Well, this is a subtracting problem, and so we need to look at, this is our original temperature. How many decimal places were there? None. And how many decimal places are in this constant? 2. So our answer then should have no decimal places. So we would round this to 85 degrees Celsius. Okay? Let's do another example. Let's convert 139 degrees Celsius to Fahrenheit. Well, we need the equation. So if we go back and look up the equation, we see that degrees Celsius is equal to the Fahrenheit temperature minus 32 divided by 1.8. Well, that's great if we've got Fahrenheit, but we were given Celsius. I am doing more difficult problems on purpose. We need to rearrange this. This is a little trickier. On the right side here, we have a fraction. Not sure why, but I saw a great t-shirt. It says 4/3 of people have trouble with fractions. Right? Yeah, you can't have 4/3 of people, right? 4 out of 3 people have trouble with fractions. Cross multiply and get rid of the fractions, okay? If you're a whiz with rearranging equations, you can do this one in your head, awesome. I'm not talking to you, I'm talking to everybody else. Let's cross multiply and get rid of the fractions so that we don't get into trouble. You might say, well, I don't have a fraction on the left. Well, let's make it a fraction on the left. You can divide anything by 1 and turn it into a fraction, right? So cross multiplying, I'm going to take the top of one side and multiply it by the bottom of the other side. And then I'm going to take the bottom of the first side and the top of the other side and multiply those. That's cross multiplying. So we're going to get degrees Celsius times 1.8 is equal to 1 times temperature in Fahrenheit minus 32. Everybody okay with that? Now, remember, I'm trying to get degrees Fahrenheit by itself. It's subtracting 32. I need to get rid of this 32. If I add 32 to that side, then all I've got is degrees Fahrenheit. That's what I'm trying to get by itself. If I add 32 to one side, I have to add 32 to the other side. So this is the Celsius temperature times 1.8 plus 32. Oh, that was poor planning. It's equal to Fahrenheit temperature. So the Fahrenheit temperature equals the Celsius temperature times 1.8, bless you, plus 32. So Celsius temperature is 139 times 1.8 plus 32. (139) times 1.8 plus 32. 282.2, and then the unit would be degrees Fahrenheit. Did you get your calculator to show you that number? On this one, I don't need to do anything tricky with parentheses or anything because my calculator understands that we need to multiply before we need to add. And so we're just fine. How should I round that number for sig figs? Celsius Fahrenheit conversions are really messy for significant figures because there's multiplying or dividing and adding or subtracting. So I'll tell you a shortcut. However many decimal places is in your initial temperature, that's how many you should round your final answer to. So 282.2, my starting number had no decimal places. It was to the nearest 1 degree, and so I want to round this to the nearest 1 degree, and I'm going to express this answer as 282 degrees Fahrenheit. Any questions? Round temperatures to same number of decimal places as original temperature. Okay. Let's do minus 321 Fahrenheit to Kelvin. Temperature conversions need equations. Let's look at our equations. Is there one that has Fahrenheit and Kelvin? No, there isn't. We have to use both of them, one after the other. Sorry, I'm lost in my slides. I'll find myself. There I am. So what I need to do here is I first need to convert the Fahrenheit to Celsius, because I have an equation for that, and then convert the Celsius to Kelvin because there's an equation for that. Could you make an equation that does Fahrenheit to Kelvin? You could, but you're not going to need it very often. That's why it's not printed in your book. It's just faster to just do it like this. So, Fahrenheit to Celsius. The Celsius temperature is equal to the Fahrenheit temperature minus 32, that whole quantity divided by 1.8. This time I don't need to rearrange the equation. I'm going to take my Fahrenheit temperature, which is negative 321, and I'm going to subtract 32, and that quantity divided by 1.8. Now, there are pitfalls in doing this on your calculator. That's a negative 321. So put in 321 and use that negative sign. Now, sometimes you have to put the little change sign thing first, and sometimes you have to do it after. Make it a negative 321, and then subtract 32. Now you need to tell your calculator, I want you to finish that. The way I do that is I just press equals, and it shows me minus 353. That's the value of the numerator, and then I divide by 1.8. The alternative is that you can actually put these parentheses around those numbers, and that will work as well. So when I do this, I get minus 196.11 repeating, and the unit would be degrees Celsius. Make sure that your calculator will give you that number. Now that I have the Celsius temperature, I can use the equation to convert to Kelvin. Kelvin equals the Celsius temperature plus 273.15. So I'm going to plug in my Celsius temperature of minus 196.11 repeating, and I'm going to add 273.15. I still have that minus 196 in my calculator, so I'm just going to leave it there, and I'm going to add 273.15. And my calculator shows me 77.0388 repeating, and that would be kelvins. Not degrees Kelvin, just a capital K. Did you get the number 77? Now, how should we round that? What did I tell you in the previous slide? Round to the same number of decimal places, right? So this number, 321 negative, is to the nearest 1. There's no decimal places. So I should round this to the nearest 1. We're not counting sig figs because we've got adding mixed up in here. And so this equals 77 Kelvin. Any questions?